Dear fellow coders, welcome to day 5 of Kaggle's 30 Days of Machine Learning Challenge. This is the second part of day 5. In this section, we're going to learn about loops and list comprehensions. If you have not seen the first part, that part is where we discussed about list. Please check it out first and then come to this video. So now, what is a loop? As the name suggests, a loop is a way for you to execute a code repeatedly. So you want to execute the same code repeatedly over and over and again, and that is where you use loops. For an example, let's say you have got planets like this. In the previous section we saw this list where we have got the planets name. What if you want to print all the planets the same line? So the simplest way for you to do is you take this planet object and then you iterate it on this. Like this is like an iteration. For every element you're going to print with the space. For every element you're going to print with the space, and then the result looks like something like this. So now this is how you use for loop. So a better example would be like, let's say if you want to print numbers from 1 to 10, so you can use for loop. So that's like slightly a better example. For example, now let's look at the syntax of for loop. So what is for loop? How for loop is defined? A for loop is defined with two important components. One is this component, which one is the iteration, like on which the object on which you want to do the iteration. Like for example, in this case planets, the set of values to loop over. So the value on which you are going to iterate. So that when we say the value on which you are going to iterate, which means you can probably think that it should be something more than one, that then only it makes sense, right? Otherwise it doesn't make a lot of sense. So it would be either a list or a dictionary or a tuple or something like that, but something where you can loop over, like set of values. That's what this component is. And then the first component is every time you iterate, this value gets assigned here. Like for example, if you look at the first time, this gets assigned. For the second time, this gets assigned. For the third time, this gets assigned. For the fourth time, this gets assigned. So for every iteration, something happens. And that, how do you capture that? That is what you capture with this planet. That's what you capture with this. So now this is the object on which you're going to iterate. This is the object name, the variable name, where you take this particular value and assign it. So anytime you use this value inside the loop, so now you know by this time, we have a colon, so we have indentation, so this part is inside loop. So anytime you use this value inside the loop, so for that particular iteration, whatever the value is, for example, for the first iteration, Mercury would be the value. For the second iteration, Venus would be the value, and then you can get it. One big difference from Python and many other programming language you would have probably seen is, you would have seen usually that people would write a for loop with index. So instead of having in like this, what many programming languages you would do is you would do for I is equal to 0, I less than equal to 10, and then I plus plus. So there are two things that you would do in other programming languages, which is like you increment one, and then the other thing is you would also have a condition until which you want to do it. In Python, you don't have to do like that. You can actually iterate over the element set of values than using an index to iterate. Like you don't have to say planets of 0, planets of 1, planets of 2. You don't have to do any of those things. You can simply take planets and you can iterate on top of it and simply connecting it with in. So every time planet in planets, so you have to just give a meaningful name. You can give I in also. You can give anything here. It doesn't have to be this name. You can give anything, but whatever that is in planets means every iteration it will go one by one, and itself will increment also. So it itself goes and then it increments. You don't have to do that increment also. And when it reaches the last one, when there is no more element left inside planets, the like value set of values on which you are iterating, then the loop would come to an end. So it would exit this loop. So that's it. So the loop will start from the first element, will go till the last element, and every element's value get assigned here, and you do whatever you want. And once it reaches last element, after the execution, it comes out of the loop, and that's the end of the loop. This is quite straightforward and simple, and you can see in operator or in variable, whatever in keyword is what links these things. So basically whenever something supports iteration, an object, you can use in, and then you can loop over it, you can iterate on it. So like for example, it could be a list, it could be tuple, it could be anything like dictionary, anything that has more than one value, you can iterate on top of it. Okay, now for example, here we saw list. This is a tuple, remember, this is a square bracket, this is a parenthesis. So parenthesis defines a tuple. So now you have tuple, you are going to iterate on it. So every time there is a new value, so 2 into 1 is equal to 2 into 2, okay, so it's actually multiplying everything, it's multiplying over and over. So if you notice one thing, you might notice when the loop started, the value of product would be 1, right, when the loop started. But in the second iteration, when this is 2, the loop has already product which is 2. So 2 into 2 is 4. Now the third iteration, loop is 4, product is 4, and you get 2 here, 4 into 2, 8. So that is how it is multiplying. So again, this is another example of how the value of product actually changes within the loop. So you're not using a new variable, you're using the existing variable, but you are overwriting it over and over again, so you can generate that that kind of multiplication that you want. Next thing is, like I said, you can iterate on a group of values. A string is also kind of a group of values, which means you can iterate it on top of a string as well. So now, like, notice this is not a tuple, this is not a list, but this is a string. So a string is also a group, set of characters, set of values. So what the loop is doing is, it says for character in S is the object, for character in S, if character is upper. So now you know that this is a method that is associated with the character. So it's going to check whether it is an upper character, uppercase, capital letter. If it is a capital letter or uppercase, it is going to enter inside this condition. Like for example, now we are inside the loop. Now in this we are inside if. So for these it will not be true. But when it comes to age, it's going to say, oh, age is upper, so I will print age. And then again nothing will happen. But when it hits E, then it is an upper character, so it's going to print E. So that's how hello is printed. So within a loop, you can use if condition, or most likely you would use if condition to optimize how the loop should exist or loop should function. So you are basically controlling the loop with a control flow. So this is quite common, using if with loop, so you can check. So we have a variable set of values which is a string. One learning for you is that you can iterate it on string. Second learning is that you can use if and a method. This method would of course return a Boolean value which is either true or false. So whenever it is true, it's going to print this. Whenever it is not true, it's not going to do anything. And finally, when it reaches this dot, nothing is happening, so it would exit the loop, it would come out of the loop. And that takes us to the end of understanding loops. Now what if you want to generate a sequence of number? I told you that in traditional programming languages you would probably do like this, like for I is equal to 0, I less than 10, I plus plus. But what if you want to do a similar thing? You want to generate a sequence of numbers. The function for that is range. When you say range of 5, it will generate a sequence of number from 0 to 5, 0, 5. So it will generate numbers, so you can repeat this for 5 times. So 0, 1, 2, 3. So you, like, range is such a function. You can see how, like, what other attributes or arguments are there in range, so you can learn those as well. But for now, if you want to iterate, you can use range and then generate a sequence of numbers, and then you can repeat it. For example, let's say you want to print a fifth table. So now what do you need? One side you need number 1, 2, 3, 4, 5. The other side you need 5. So now 5 is constant, but you need to generate from 1 to 5, right? So that you can generate with this range, and then you can multiply it here, and then you can print it. And the syntax stays the same, like in stays the same, which also means you can have a function here. The output of this function should be a set of values which you can iterate. So simply range is quite used commonly. Next, now for loop is finished. What is a while loop? Okay, now if you see the primary difference between for loop and while loop is, for loop would end. Okay, for loop would end when the end of the last element, like, or the last element of the iteration of the value that you are iterating on. So there is a variable, and that variable, when it hits the last of that variable, for loop would end. It's quite simple, right? By default, like this would end when it hits here. But what if you want the end to happen based on a condition, not based on the elements? what if you want the end to happen based on a condition, or I should even say, what if you want the loop to happen while a condition is met, while a condition is met, while a condition is true, while something is happening. What if you want the loop to keep on happening, and when the condition fails, then you want the loop to stop? And that is where while is extremely useful. While happens, while everything inside while will happen until the until the condition is met. For example, I is equal to 0. Okay, now what we are saying is, while I is less than of 10, which means until I is less than of 10, that's what while is, right? While I is less than of 10, this will keep on happening. I is less than of 10, so I first is 0, then I plus equal to 1, which means you are incrementing I's value by 1. So next is 1, then it will check here, is it 1? 1 is less than 10, yes, 1 is less than 10. It just keeps on happening. After it prints 9, here I plus 1 is 10, right? When it goes here, it will see, oh, whether 10 is less than 10. No, 10 is not less than 10. So condition failed, loop exits, it comes out of the loop. So that is how while works. So basically you need a Boolean here, and that Boolean should stay true, and as long as that Boolean is true, this gets executed. So that is how while is. So while the Boolean, the condition is true, this gets executed, and when it gets false, this will exit the loop. Again, while is useful in certain conditions, like when you don't have an iterator but you want to do a set of operation, you don't want to rely on an iterator, you can just use some while condition like this. That takes us to the end of entire loops. So we learned about for loops, we learned about while, we learned about in, we learned about what all things we can iterate on, we learned about while and how to exit. So all these things are fine. While you are writing while, you should keep one thing in mind. By mistake, by any chance, if you do a mess up here, which means if it is going to be true, this loop becomes a never ending loop. By any chance, right? By any chance, if this is true always, which means your loop will never end, so that will probably crash your machine. So just remember that this is one of the beginner's mistake. So it is entirely possible that the condition that you give could be wrong semantically. I mean, like, it might not throw any error, but semantically it might end up being wrong, and then you might be running a loop forever. So just keep that in mind. So now we are entering into a very interesting subject that's quite unique to Python. A lot of people love it, some people probably may not. So this is called list comprehension. So until now we learned about list, and then we learned about loop. What if I could combine these two and then reduce the number of lines of the code and make it more readable, just like English? Okay, so the idea is, what if I can combine list, and what if I can combine loop and then make it more readable, like reading a comprehension, like more understandable just by looking at the code rather than the traditional way of writing loop. So now I think it's quite abstract. Let me say, look at this code. There is a list, and inside that there is a loop. Now what do you understand from that? So if you are from a traditional programming language, any programming language, you might have a little bit of issue in understanding this, right? But what if you are from no programming language? Just look at it and read English. So what is it? We know double star is square. Okay, double star 2 is square. Okay, n square for n in range of 10. Now let's take a pause. Okay, now what if we try to dissect it? So let's say we want n square. So n square is our output. N square for every n, let's say number, okay, number square. Let's say this is number square. Number square for every number in a range of 0 to 10. So does it make sense now? Let me repeat it again. N square for every number in the range from 0 to 10, which means for every number from 0 to 10, just create a square and give it back to me. That's what we are saying. So we are saying for every number in the range of 0 to 10, give me the square back, and that's it. This is list comprehension. It's quite easy to understand if you are not familiar with the loop structure. So instead of doing something like this, we are doing list comprehension, which means for every number. So this is your output. The first section is your output. Then you write the loop. That's it. Your output section. Then you write the loop. So if you have to write it the same thing, The same thing using the traditional for loop. This is how you would write. So you would initiate an empty list, then you would write a for loop, and within that for loop you would say like every time there is a value appended back to this, and then you would return the list. So instead of writing 1 2 3 4, which may not be easy to understand, like it is not pure English, right? I'm not going to say, oh, I've created a list, then I'm starting a for loop, and within the for loop I'm going to create square and I'm going to append it back to the list, and then I'm going to print the list. Instead of saying like this, what is quite English is square for every number in the range of 10. So this is more English, more readable, more understandable. So that's what list comprehension is, as simple as that. Now, can we have if within a list comprehension? We know like we can have a if within a for loop, right? So can we have if within a list comprehension? You can absolutely have if within a list comprehension. Let's see what this happens. Let's again try to read in English. Okay, planet, give me planet. For every planet in planets, if the planet's length is greater than 6. Let me say that again. For every planet in planets. Planets is a list of planets, okay? So let me call it list of planets. For every planet name in the list of planets, if the list of planet, if the planet name is less than 6. If the planet's name is less than 6, check this for every planet, and then if whatever is true, give me the result. That's what we are simply saying. So let me repeat it again. Give me the planet name for all the planets only if the planet name is less than 6. That's what it is. So we are going to iterate through every planet, and then we are going to check for every iteration whether the length of the planet, which is the name, is less. So Mercury is not there, Jupiter is not there, Neptune is not there, because their names are not less than 6. So whatever the planet whose name is less than 6 characters, when you use length on a string, it will give you the number of letters, characters. Then you would return the planet. Again, like you said, like we saw before, this is quite simple, and one single line you can understand. If you are struggling in this particular explanation, please let me know in the comment section so I can try to explain you. So list comprehension could be slightly confusing at the start, but if you have a fresh mindset, if you just forget about for loop for a minute and then think fresh, you might easily get it. So we have a condition that gets evaluated for every iteration, and when the condition is true, whatever we define here is printed out or appended to the list, and that list is given back to us. So for every planet, like give me the planet if the planet name is less than 6. Again, this if condition is more like your where clause. If you are familiar with SQL, you would have written a where clause at the end, right? You would say select star from this where this. That's how you would write a SQL, right? So this is similar like this. Select, give me this from this when this is met, where this is true. So that's what it is similar to. If you do not know SQL, don't bother about it, but if you want a career in data science, you should definitely know SQL. I don't know whether this is going to be covered in this program, but yeah, you should learn SQL. So that's my digression to the topic. Okay, nice. Now what if, like, we learned that we can write for and then we can have if, but what if I want to do some transformation before I append it? Like, what if I want to convert this into uppercase, like this, before I put it inside list? Quite simple. Why quite simple? This output, you can do anything here. Like any operation, transformation, function you want to do, you can do here. So instead of just taking the planet, you can actually do planet.upper, which is the method that will convert the existing string into uppercase. So basically what they have done here is they've taken the planet, converted into uppercase, do a string concatenation. Plus means like you are combining two string concatenation with exclamation symbol, and then they are adding it to the list. So basically before this for, you can do anything. You can basically do anything, and that will get added to this list. So it's not just that you can control here, you can actually add whatever you want, transformation, operation, function, whatever it is, and then you can do it. You will get the result. Okay, another small variation is sometimes people write it in single line, but sometimes for readability, to have a clear structure, people might write like this as well. These This one and this one is same. It's just that it is better in reading. You see, there is no indentation. There is no colon, because this is still list comprehension. It's not a separate for loop. So that's why you don't see colon here. So you don't see a colon here. You don't see a colon here. Unlike your traditional for loop and if. But people write it in separate lines within the square bracket so that it is more readable. Oh, I'm trying to make uppercase and add ampersand for every planet in the planets list if the planet value is less than 6. So that's more readable, and step by step you can understand what is it. Again, like I said before, this is very similar, like select star from blah blah blah, from is this, and then where is this. It's quite similar like that. Now a question, what if you give something like this, 32 for planet in planets, what will happen? What do you think will happen? Just guess. So you have 8 planets, okay, you have 8 planets and you say 32, what will happen? Just think for a minute. So if you put planet here, it will give the planet name, which means you are trying to access the value in every iteration, element in every iteration, you are trying to print it, like adding it to a list. But what if you give a static value, like you give one value, what will happen? I think if your guess is right, if your guess is right, it would look something like this. Did you guess this? Let me know in the comments. So what is happening? Instead of having a dynamic value, which is planet, or doing anything with planet, you can actually give a static value. So this is like, you know how we write a for loop, right? Like a while loop, right? So while there is an element in planets, just print 32. That's it. Or for planet and planet, just print 32. So you're basically printing 32, nothing else. Okay, don't spend so much time, but you can just understand. So another thing is, you can combine list comprehension with min, max, sum, any function that you want, and then you can generate impressive one-liners. For example, if you look at this function, the function is supposed to count the number of negative numbers in a given list. Okay, so how do you do that? You basically take each element, iterate it over, and then try to see whether this element is less than 0. And if it is less than 0, you can have a counter and then you can increment the counter, right? If it is less than 0, you can have a counter and then increment the counter. So for example, starting the counter is 0. Okay, so now your first element is 5 here. When you see 5 is less than 0, no, it's not. So it will not go inside if. It goes back to the loop. Minus 1 is less than 0. Yes. Now 0 is equal to 0 plus 1. So now n negative is 1. So now when in the third iteration, minus 2 is less than 0. Yes. Now 1 plus 1 is equal to 2. So 2 is going to be your output, right? So two negative values are there. But what if you want to do list comprehension? You can simply do like this. You can create a function which is count negative of numbers. So now you can say, give me the number, okay, give me the number where number is less than 0. Give me the number where number is less than 0 for every iteration. So you are basically extracting the negative numbers, creating a new list, and then from that list you are calculating the length, which is as same as this, but because you have done it in list comprehension, it gives you more more flexibility, like more simplicity. But what if you can do something more? Like what if you don't want to use if condition here? What if we can take advantage of Booleans? If you remember, in the Boolean section we saw, when you try to add two Boolean, like true plus true will get evaluated as 2, because true is 1 plus 1 is equal to 2, right? True will get evaluated as 1, and then 1 plus 1 is equal to 2. What if we can leverage that and eliminate our code further? For example, for every number in nums, give me the Boolean value. Here you are doing an operation just like how you did upper, number less than 0. So whenever number is less than 0, you will get true as output. Whenever number is greater than 0, you would get false, and false would get evaluated as 0. So you don't mind about it. So you mind only when number is less than 0, which is true. So it will be true for this. Okay, first time it is 0, second time it is 1, third time it is 1, fourth time it is 0, it is 0. So now when you sum all this, 1 plus 1 is equal to 2, and that's what this function is. So you can keep on doing this kind of stuff, but there is one important thing you have to like remember from the Zen of Python. Readability counts, explicit is better than implicit. See these two are like trade-offs. Imagine you can be as implicit as possible, but your readability might suck. But you can be as explicit as possible, but your readability may not be very good. So just understand the trade-off. Just think, when you write a code like this, will somebody new will understand, or when you write a code like this, your peers, colleagues will understand. So make sure that the code that you write somebody else can understand. So there is a trade-off between how short you want to write your code, how readable it is. So always find balance between these two and then do it. So that will help. So in this section we learned about list comprehension. We started with loop, we started with for loop, we started with while loop, we saw a couple of functions. We learned about list comprehension. We saw how far list comprehension can go in compacting or making the code shrinking, and that's a good thing. Many people like it, some people do not like it. So you just have to understand the situation and make a trade-off. Now we are going to get into the challenges section. So what are the challenges? Again, my usual disclaimer, it is always good for you to write the code yourself. Do not copy paste, do not follow me. So do the code exercise yourself, and if you still are stuck or you want to see how am I solving, you can come to the section. Otherwise you should just stop the video, pause the video here, and then go do your exercise yourself. So that is the best way for you to learn programming. Otherwise you will be always dependent on some video tutorial, which is not ideal, right? So that's not the whole point of us learning this thing. My mission is getting started. Thank you, Kaggle, for giving me this mission. For all of us, right? It's not only for me. What's the first question? The first question, have you ever felt debugging involved a bit of luck? Or debugging, if you are not familiar with programming, debugging is the process of identifying an error. A bug is an error, identifying an error and then fixing it. Debugging is basically finding an error and fixing it. Okay. The following program has a bug. Try to identify the bug and fix it. Okay. What's a bug? If I run this, will it show an error? Oh. Try to identify the bug and fix it. Let's first try to see if it shows a bug. Has lucky number. I'll give 10. It throws an error. What is the error? Int object is not iteratable. That's the error. So it says int object is not iteratable. So which means we have used something inside this that's giving error. So first maybe I have to give a list 10, 10, 7. Okay, let me do this. Now it gives false. So now what is the function supposed to do? So the error is not a syntax error. Now the error is semantic error because the code gets executed. Okay, the code is getting executed. So the error is semantic error. Semantic error means there is a logical error, but not syntax error, not the error in the way the code is defined. So return whether the given list of number is lucky. A lucky list contains at least one number divisible by 7. So ideally this has to be true because at least one number should have, like if there is at least one 7, a number divisible by 7, then your output is true. Okay. So now what is the error? For num in nums, return true. So what is happening here is, now do you think it went two sides? Like do you think it actually executed multiple times? No. When you use return here, it exits the loop. It exits even the function when you use return. So what has happened here is, when you have, like if I say 7, 10, it will say true. You know what? You know why? Because the first num, value of the first num, which is 7, it will say true. So it has exited the loop. But what is the condition? The condition is one of the elements should be divisible by 7. So it could be anywhere. So now how do you fix it? You can fix it in multiple ways. That's one thing. So one thing you can probably do is, it's a naive way. You can do is, instead of returning here, you can create an empty list. I can create a list like what do I say? Lucky list. Okay, lucky list, and then I can keep it like this, and then I can say I'm just doing it slightly, lucky list dot append true. So I'm appending true. Okay, and else I'm going to append lucky list dot false. Not required, but I'm just simply doing it just to make it more readable. You can simplify this code, which we'll see in the further section. But again, so I'm having an empty list. Whenever anything meets this condition, I'm saying append true. Whenever anything meets this condition, I'm appending false. So at the end of the loop, I'm going to say if sum of lucky list is greater than 0, which means at least one is true, then return true. Oops, did I just okay, sum of 0, like this. Okay, it should ideally work. So did it work? I think it should have worked. Return true. It didn't return anything, right? For some lucky if else, and if sum is greater than else. False. Okay, let's run this. It's giving false. Is it giving false because there is a lucky list? Okay, you know why it is giving false? Because the list gets initiated every time. What a dumb way to write a code. Okay, now it's true. So now even if you say 99 and 7, it will say, if you say 1 7, it will still, because you have 1. If you do not have, oops, okay, because you have got 0, let me say 8, it says false. Okay, 9 8 false. So basically whenever there is 7, it would say it is true. Whenever it is not 7, like if there is no 7 at all, it will say false. Again, this is not the efficient way to write, but I'm just explaining you my thought process. Create an empty list, and if anytime it is true, just append it, and then anytime it is false, just leave it. So probably the easiest way to do this is using list comprehension, and which you can check with the solution, or I will leave it you to write it. So maybe you can do it easily. So the next thing is, but we solve the question. Okay, the next thing is, look at Python expression below. What do you think we'll get when we run it? What do you think we'll get when we run it? So let's try to run it. It shows error. Why does it show error? Because greater than not supported between instances between list. So it's saying that you're trying to compare an integer and a list, and then we don't support this. That's what they're saying. But you have to remember that there are some libraries in R and Python like NumPy and Pandas, where you can actually compare a list with an integer. Like you can compare a list with a scalar value, and that would do element wise. For example, you can still do this. Like you can still do this. Sorry. Oh, this is not possible. Okay. But yeah, so this is operator overloading, but this is not working. And that's because element wise comparison does not exist. So now can you implement a function where you can get this return? It's quite simple, right? So let's say this is a question number 2, right? Is this a question? Okay, yeah, this is a question. Returns the list. Return a list with the same length as L, where the value at index is true if L is greater than the threshold. Threshold is a condition, so like 2, and list is list, like this, and you have to, based on if this is your input, right, you have to return a list like this. That would give you the result. Okay, so for element in L, which is our list, again let's try list comprehension this time. Let's not try the other way. Okay, how do you first write a for loop? For element in L. Okay, that's your this thing. Now what do you want to know? You want to know if element is greater than threshold. So basically you are saying if for every element, give me what is the element greater than threshold. Okay, run it. It's incorrect. Why did it give incorrect? When you say thresh is true, 2. Okay, we forgot to return. I think this is my regular mistake. Correct. Okay, so what we did is for element is greater than thresh for element in list. Or you can write a for loop like this, but again this is single line, right? And this is more English. If element is greater than threshold, then for every element just return whatever it is. The third question is complete the body of the function according to the docstring. Given a list of meals served over a period of time, return true if the same meal has been served 2 days in a row. 2 days in a row. So consecutively, if the meal is served the same, false otherwise. So the hint is that you have to use index, okay? And the best thing is you define an example like this and then you work on top of it so that you can get some idea. I will leave this for you to solve, and I will leave this as well for you to solve. So the two questions I'm not solving, but I want you to solve. And if you face any issue, please let me know in the comment section, or you can come to this notebook and then you can still do it. So I'm going to save this notebook, but please solve the third one and fourth one. It shouldn't take a lot of effort. For example, you just have to verify whether the current date and the previous date are two consecutive values or same, and once you check that, you can return true. If it is not, then you can return false, and that will probably solve you. And this question again, it might take a little bit of time, so that's why I'm not solving it. So you can definitely try it out and then let me know your thoughts. So in the next section, the next new video, we are going to learn about strings, but in this video we learned about loops and list comprehensions. If you have any questions, let me know in the comment section. Otherwise, please spread the word. Let's try to do 30 days together. Stay safe.